Here we're going to decide if functions are even or odd functions. What mainly has to do with what happens when you put in a negative. Does it cancel, or does it end up making the outside of the whole function negative? And the reason why they call these even and odd is, if you notice, a lot of the ones that this happens to would be functions like if I had f of x equals x squared. Notice if I put negative, when I square it over here, the negative cancels. And maybe a good example for this one would be like x to the third. If I put in a negative, the negative doesn't cancel, so I could end up on the outside. All right, so then what does this look like in terms of the graph? We'll think if x, f of x is on here, so I get it put in output, get an input. So if x, f of x is on the graph, then negative x, so instead of going over a certain amount of units, I'm going back, but the same output because the negative canceled. So x, y, and negative xy are on there. We think of graphs where that happens, kind of like x squared. See how they're also symmetric to the y? So if this point's on here, the mirror image one across the y is on there. And then if we look at x to the third, oops. Swooping like that. So if I have a point xy on here, or x f of x, doesn't matter what notation you use, if the negative comes out, right, it doesn't cancel, you'd end up with negative x, negative y over here. So this is what's called symmetric to the origin. There's the mirror image across the origin. All right, so now we'll look at some of these, and from the function or from the graph, we should be able to decide if it's even or odd. All right, so our first function looks something like this, despite the bad drawing. So is this one even, odd, or neither? Well, it looks like it's the mirror image, right? If I have a point over here, I have the same point over here. If I have a point here, I have the mirror image point over here. So it seems symmetric across the y. So that looks like it makes it an even function. Then if I have this one, it looks symmetric across the origin. In fact, it looks just like x to the third, only it's pointing in opposite directions, kind of like negative x to the third. But we just need to look at individual points. See how here, if I have over x and down y, there's a mirror image point over here that's back x and up y. See how they have opposite signs? So that's symmetric across the origin, so that one's odd. All right, what if they just give you an equation and they want to know if it's even or odd? So we'll do this one. And this one. All right, so what we mainly want to check on both of these is, what if we replace all our x's with negative x's? So be careful, where there used to be an x, there's now going to be a negative x. Wedge my little negatives in there. All right, so what happens to negative x to the fifth? Well, the negative doesn't cancel, so we could pull it out front. We could say that's the same as negative 1 times x to the fifth. And so this negative times a negative will give us 4x to the fifth. So they canceled there. But then here, if I have negative x squared, negative x times negative x gives me positive. And so notice, this isn't the same function, so it's not even, because you'd have to get the same output as you had before. And it's also not odd, because I don't have just the negative. This one switched signs, but this one stayed the same. And so you can kind of tell if you do a few of them, the pattern of it. Notice how there's one odd term and one even term. So this one's going to be a neither. It doesn't quite work for either of those rules. All right, then in this one, negative x to the fifth, and negative pulls out, so this is negative times a negative, right, to the fifth doesn't cancel anything. So this is 2x to the fifth, and same thing here, that makes that minus 7x to the third. All right, if I think about this in comparison to my original function said negative 2x to the fifth plus 7x to the third. So is what I got the same as having a negative on the outside of my original function? Because in the definition, that's what they mean when they say, if I put negative f of x in there, do I get negative on the outside of the function? So if here's the original function, if I throw a negative outside, see how that makes it plus and minus? And so you might have been able to guess from the beginning, you actually had two odd terms, so it was going to turn, you were thinking it was going to turn out odd, but when you actually tested it, it turned out to be an odd function.